Hello, I think everybody can see me and hear me very clearly. So today we are going to start a new lesson, that is vectors, and that is the ending of the first unit. So I have to tell you one important thing. This lesson content is not that much you have chance to get more scores, even lesser than the units and dimension and measuring instruments. But the importance of this lesson is this lesson will lead you to score good marks in all the other lessons, because all the other lessons, most of the other lessons actually, you need the very basic knowledge of vectors and application of vectors, especially vector addition, good evening, and vector resolution. These two you will badly need, and the resultant vector and direction of the resultant vector theory you badly need. Okay, so I will give you a demonstration. I have given this demonstration all of the time so far, more than 2 times. I'm going to give the same thing again. The reason is there are like one or two, and I think more than about like 5 to 6 new students. They have no idea what is that I'm going to say. So let me give you that example one more time. All the students who were in my classes already know what I'm talking about. They know what I'm talking about. But for the newcomers, they have no idea. So that's why I'm just showing you. The example is when you apply a 20 Newton force on a certain 10 kilogram mass, your aim is to just to find out the acceleration. So how can you do it? The only way is Newton's first second law of motion, F equals to ma. Right? F is 20 Newton, m is 10 kg, and the acceleration will be just 2 ms minus 2. This was something you have done so far. But the thing here is, you are going to do something little bit different. Little bit different. That thing is same 10 kilogram, same 20 Newton, but along an angle of 60 degree to the horizontal. Here you will have to apply the knowledge of vectors. That is what I called your vector resolution theory. Okay, that part you will have to know. And also, can you remember I just drew a diagram last week? Not last week, the week before that. I just said like this is mg, there is a force of F, there is a tension. So this tension is resolved into T cos theta and T sin theta. And actually I wanted to show you the trigonometric relationship. So I actually drew the final diagram, and some students just asked me and say, "Sir, I didn't understand." And I said, during the time of explanation, I'm going to show you something you will understand in the relevant lesson in future. That's what I said. But they have not listened to me what I said. They said, like, sir, I didn't understand. I asked them, did you understand how did tan theta come in that one? They said, like, yes. I said, that's the only thing I wanted to you to understand. I said, this is a future lesson. This type of applications will be there. Ne? Ne? Unfortunately, they haven't heard it or something. They asked me, so I didn't understand. So the answer was for here. It was tan theta is equals to f over mg something. Then I said you will have to use some trigonometric knowledge like this. So today I am going to give you the very basic start for vectors and their applications. My aim is to finish these topics for today. The first topic that I'm going to introduce you is vector quantities, scalar quantities, and their properties. Number one, I'm going to do today is properties of vectors. Properties of vectors. Number two, addition of vectors. Addition. This addition may come in 5 different ways. In the first way is addition and subtraction of vectors in the same line and same plane. So the next all 4 methods will be addition of vectors in the same plane but at different angles. They are not parallel. First one is the parallel vectors. All the other 4 are going to be slanted vectors to each other. First thing is going to be this is the parallel and triangle theory and scale diagram. Here it is going to be parallelogram. And the last one is going to be vector polygon. I don't think we have time to do vector polygon, but I will try maximum to complete until to vector parallelogram. And I have to tell you a very important thing. So far, we had all the lessons I did very slowly and steadily and gently. During the period of time, I actually did was build up your IQ level. So you didn't even notice that. I included many questions that you have to think and think and think. You're thinking better. I just let you to practice well and laid the foundation. But today onward, I am going to shift the gear to next level and speed things up. Are you ready for that? I'm pretty sure you are ready because your IQ level is way ahead of many students in many classes. I'm pretty sure because I slowly, without even you to notice, I made that. Have you watched that movie called Karate Kid? In that movie, the master didn't actually just train him to fight. Actually, he just made some background of him, just like kind of protections, like blocking methods. He didn't even know. Actually, he has learned those things and increased his physical stamina and strength and all, and reflexes without him even knowing. The copy was a Indian one called Bagi. I also watched that one. So the same method I applied here. Now your brain capacity is more than you imagine. It's very sharp now. And I have to tell you another important story for a while, like taking only 2 minutes. A king wanted to find out the best wood cutter, wood chopper actually. Then he just invited many, and in the final round, there were 2 people. They were given similar looking trees to chop down and just preparing in wooden logs. They were given the similar axes. The one with really built body, he just started to chop the tree right from the beginning. The other person took more time and he was not chopping the tree, but he was doing something. What? He took like 1 hour and sharpened his axe to extreme sharpness. Then he started to chop the tree. he could finish way beyond other guy and saving more time, and he was just resting. Other guy was just trying to cut and cut and cut. Then the sharpness gone away. He was just in a trouble. So you are like the second fighter, but that chopper firstly sharpened the axe. Now your axes are very sharp. You can just chop. So today I'm going to increase the speed almost by double. You won't feel it because your level is already ready for that. Are you ready for the mission? Yes. Write a very big topic. Write a very big topic. Vectors. Very one, big one. Vectors. Write this in a new line. All the physical quantities in the universe can be divided into two major groups. Can you tell me what are those two major groups? First one is going to be what? Can you tell me? Scalar quantities. Yes. First one is scalar quantities. Second one is vector quantities. Yeah, as you learned earlier, it was divided into with their properties. We just divided in what? Matter and energy. Yes. Now here, physical quantity is going to divide into with their directionality actually with the nature, scalar quantities and the vector quantities. Now write a small subtopic, scalar quantities. Scalar quantities. By the way, Lamai, I have to tell you one thing. You will receive your vector tube plus linear motion tube as two different tubes, together in the next week. Okay, because vector tube is only to study purpose. All the tubes are only for the study purpose after the lesson. So it will be finishing within 2 weeks. This week and the next week, the vectors will be completely done. If you are requesting only, I will go for the third week and do many questions. But I'm pretty sure you won't ask me. If you are requesting only, I'll do extra day. Otherwise, today and the next week, the vector lesson completely will be done. Okay. You will receive in the next week both tubes. One is the vector, other one is motion together. Until then, if you want to study something, I am going to send you PDF tube. You won't even need that one. Now, right? Scalar quantities subtopic. The definition of the scalar quantity is physical quantities with only a magnitude and no specific direction. Physical quantities with only a magnitude and no specific direction. These are known as what? Scalar quantities. Okay. Good example is distance. Distance is a very good example. You start from some point A and to B. I can just bring this line to here, traveling very long distance, even 1,000 kilometers longer. Why? From here to here. Because distance can take any amount. Okay. You have seen this scenario when you are going to up country, somewhere like Rakwana, and like even when you are going to Kandy around, what is that place? Kadugannawa. You might have experienced the same thing. This type of road, not you can move directly. Somehow you have traveled many long kilometers only to climb like 100 meters from that position. That's how it is. So the distance can take any value. So only has a what? Magnitude. But there is no specific direction. Why? It changes. It changes to all 360. No specific. Understand? Right. No need to copy this. Distance is a good example. Right, this next one. The speed is a good example. Speed, mass. You can't say the mass towards there, towards here, towards up. No, just mass. Mass, time, temperature, amount of substance, luminous intensity also, and energy, power, enough. Now start to write. Next small subtopic. Vector quantities. Now you have to know what are the vector quantities are. Vector quantities. Okay. Vector quantities. Okay, Ramai. Let's start. What is vector quantity? Now write this in a new line with the definition. Physical quantities with magnitude and a specific direction. And a specific direction. And a specific direction. Specific direction. Known as what? Vector quantity. Vector quantity. Okay. Right. Let's write a good example. Write it like displacement for a scalar distance. For a vector, displacement. Why? How to do that? If you draw a straight line, you can only draw one straight line in that direction. You can't draw thousands of straight lines in the specific direction. Specific means when you directly look at B from A, there is only a one direction. This is a vector. Displacement is a vector. Now write the next thing. Velocity. So in the previous one, speed was a scalar. Here velocity, it is a vector. Okay. Vector. Okay, Ramai. Now write more examples. Acceleration. Force. Okay. Momentum. Current. Current is also a vector. In a conductor, you can mark the direction of current like this. So it is a vector quantity. Okay. And magnetic field intensity, it is a vector. It is from North Pole to South Pole. You will learn these things in future. It is a vector. There are many more. There are many more. Okay, Ramai. That's it. Now we learned the examples of vectors. And now we have to learn the way of representation of vector. If there is a thing, have a good look at. If there is a thing called force, how do you represent force? In a symbol of F. Likes of pressure, you represent using P. Like in the same way, amount of energy, you represent in a unit called joule. Like that, you should represent certain vector in multiple ways. Yeah. Moment of force is a vector. You have a rule called corkscrew rule, right hand grip rule. I will teach you this in that relevant lesson. You will get confused. That's why I don't want to give you about moment anything. Because there is a specific lesson for that. You will be able to learn that. Okay. Like in a similar way, you have to represent the vector in specifically. Let's see how we are going to represent that. Write this in a new line. Number 1, represent the vector. Represent the vector by means of an arrow. By means of an arrow represent the vector by means of an arrow in the way of magnitude and the direction. Have a good look at. Now, see, you are just going to represent something, certain line in a grid. Grid means XY coordinate system. Here you have X coordinates. Here you have Y coordinates. Right. If this one is fully scaled from this point to certain point like this, if I draw certain arrow, won't you be able to count the distance using these grid lines? Magnitude using these grid lines? Podigale, in grade 6 and 7, you have done this type of coordinate system drawings many million times, haven't you? I'm sure that was in year 9, sorry, year 6. When you draw this type of line, you are representing here the x1, here y1 coordinate, here x2 coordinate and y2 coordinate. You mark these points and you used to draw lines to represent whatever the change. Year 6 mathematics. මතක නැද්ද? I think year 6 mathematics. If you draw any this type of coordinate system, that means you have marked within a scale. Even in a graph paper, if you perfectly scale it, you can mark it. Give me a 1 minute. I think that glitch is over. Can you understand? Yeah, it is about Cartesian planes. Yes. Cartesian plane in grade 6. Like that. Don't remember these things. I just asked you a simple question that you have done many million times. Like in the same way, if you want to represent certain vector of V, you can draw a straight line like this and draw an arrowhead and mark it like V. Can you understand? Can you understand this? You can represent any vector with a line and arrowhead. Okay, draw this very quickly. And give me a 1 minute. I am just with the wrong markers. Okay, Ramai. Now write the length of the line. The length of the line represent the magnitude of the vector. The magnitude of the vector in a certain Cartesian plane. Cartesian plane. Magnitude of the vector in a certain Cartesian plane. And write this in a new line. And the arrowhead represent the direction of the vector. Okay, Lamai, have a really good look at. You will understand this now. Okay. This is like 100 meters to left. To left. Sorry, to the right. To right. To right. Okay. That is the direction. 100 meters. Now you are going to represent another 20 meter in the same direction. How? Small arrow, why? In the same Cartesian plane, if you draw the same length, that means it will again represent 100. Because you have to be really careful with the scales. See, this is 100 meter. It should be a long line. This is a very short distance of 20 meter. So it should be a very short line in the same scale. Can you understand what did I say? Also to left, to right, sorry. Okay. Lamai? Hello? Okay, copy that. See this pen? Mainly. සෑහෙන දවසකින් ආයිත් මේ මම ක්ලාස් කරන වෙලාවෙම ඇවිල්ලා. Can you see? This is my pet. Okay. Lamai, I think you copied this, ne? Okay. Right, Lamai. Now, right, there are multiple ways. This is just a one way. Just a one way. I will show you many multiple ways. Right? This is the good way. See, you can represent certain vector with a certain arrow in the top. You can represent the same vector with certain dash line up. You can represent the same vector with a certain dash line just bottom of it. You can represent the same vector inside the square bracket like this. You might say like it is the way of represent what? What? Can you remember something like this we did? Very recent? Like 1.5 months ago, we did something with the square bracket. What is it? Two-dimension analysis to represent the dimensions of. So that is the same symbol we use again and again and again for many multiple things. Okay. So sometimes we use this type of notation, and sometimes dot, and many ways. So my favorite ways are just the graphical representation with the magnitude and direction, and this one I normally use, and I very rarely use this one and this one too. use okay, copy these things. There are many ways, many more ways. Okay, copy this. This is the graphical representation. All the other symbol wise representation. We just mark this with actually with the sign component of that one too. But I will tell you what that in magnetic lesson. Not now. Shall I erase? But I normally use this one, and rarely use this. Sometimes this one. Okay, Ramai. We now know how to represent. Now we need to know what are the very basic properties. Now write this in a very important notation with the triple star point, triple star or 5-star at least. Sometimes write this. Once a direction is chosen, once a direction is chosen for certain set of vectors, or you can write like system of vectors in a bracket. System of vectors in a bracket. Okay, close the bracket and write this in a new line. Sorry, in the same line, no problem. That is the positive direction of the vector. Okay, again like this. Vector. You chosen that to write. Okay, right hand side is the positive direction now. Right hand side is the positive direction now. Now have a good look at. You can't change the arrow after that. After that, you can't change the direction of the arrow because you have given the positive direction as here. Here. Now it is something like this. Let me show you that with good example. Okay, now imagine this is one of my certain stupid finding. It was like not a finding. I actually made this to make some kind of like electric regulating gun, stun gun, something during the COVID time. Because COVID time, all the like goons and other people used to come to rob. So this one was a very good weapon, but I hadn't had chance to use it. So imagine like I'm holding this to attack certain enemy. Okay, it's a very funny thing because it makes some good arc between. Now I'm holding like in this position. I'm just moving forward, but it is very small passage. The height is also very small. If I turn it makes sound with attacking, knocking against some other parts. So I want to work, but slowly and steadily. Now I hear certain sound behind. I want to turn back, but I can't turn because the walls and other things are there. What can I do? How can I just check the behind? I can only walk back. Isn't that? Ne? Huh? I can't turn. I can only walk back because I have chosen my direction as the positive direction here. I can move forward, but I can't turn like this. I can only do is I can walk back in the reverse direction. Can you understand? That means you can't change the direction of the vector once you just identify certain direction as positive. Understood? Yes or no? Others? You have to understand this one very badly. If there is anybody who can't understand, just let me know. It is very, very important to get to know. Yeah, ne? Okay. Now write equivalent vector. Equivalent vector. Equivalent vector. Equivalent vector. Equivalent vector. Equivalent vector. Now, can you remember this thing? You used to write equivalent fractions of 1 over 2. It is as same as of what? 5 over 10 and 20 over 40. 1000 over 2000. All these are equivalent fractions because the value finally will be equal to 1 over 2. Like in the similar manner, you will have to find certain vector exactly copy of this. Exactly a copy of this. Okay, that is what called equivalent fraction. You don't want to remember any definition for this, but if you only need, you can write like a vector which is equal in all the aspect to another vector is known as what? Equivalent vector, all the other aspects. But no need to fill your book with unnecessary amount of definitions. Otherwise, you will have no idea what to study, what is not to study. So, no need. If there is a vector exactly like this, so it should have following properties. Number one, right? Both the vectors should be the similar type. Okay. If this is a force, if this is the length, are these two equivalent? Huh? This is like 8 Newton. This is 8 meter. Are these two equivalent? No. It should be the similar type. Actually, you don't want to recitate these things like poems. You can just understand with the logic. Okay. It is like V1. Other one is V2. Rather than I will use like X and Y. I will use, you might think only all the time you need to use V, no, any vector with F1. Okay. This is like F2. I will use like that, F2. This one is a force. This one is also a force. Right. Same type. Number one, same type. So that is satisfied. Now the next thing is parallel to each other. If one vector is to here, an equivalent vector is to here. No, it will never be an equivalent vector. Why? It's not parallel. So second thing should be parallel to each other. parallel to each other. Right. That is also something you should know. Parallel to each other. Don't worry about my writings. I'm just writing it for my satisfaction. I have already said what is the first one. Same type. Second one should be parallel to each other. Don't look at and try to write. Can't understand parallel. Okay, imagine there is a 10 Newton force to here, to the right. There is another 10 Newton, but upward. Are these two identical? I said all the aspects, not only one aspect. Same type force, yes. But if the directions are, these are not parallel, one is upward, this one to the right. No, these are not the same. They are moving in two different directions. Second scenario should be, it should be parallel. Otherwise, you can't say it like an equivalent. All the aspects. Number 3 is in the same direction. In the same direction. Why? You might say parallel means same direction. No. If you walk in, going highway or any road, all the vehicles traveling in your direction, they are parallel and in the same direction. The incoming vehicles towards you, you move to their parallel, but one is moving to the forward, other one is moving to the other side. They are not in the same direction. One is to the parallel, yes. Arrowhead should also be in the same direction. Understand? If this one to right and the other one to the left, they are not equivalent, right? Because these two are in two different directions, in the same direction. Last thing is, should have the same magnitude. Imagine if this is 10 Newton, if this is 8 Newton, it is not going to satisfy. So the fourth factor is what? With the same magnitude. Should have the same magnitude. Should have the same magnitude. Understand? The magnitude should also be same. If all these scenarios satisfied, we used to call this vector as an equivalent vector. Understand? Understand? Okay, Lamai. Now start to write this important point. Very important point. After writing this, with a double star point or triple star point, equivalent fraction, sorry, equivalent, not fraction, equivalent vector, equivalent vector can place anywhere in the system parallel to the positive direction. Anywhere in the system parallel to the positive direction. This might be really confusing to you. Give me 1 minute. Now have a good look at. You are applying a force on an object from the center, 10 Newton. There is a thing called moment create. It is a different case, but the application of the force, you can remove this from here and attach to the 10 Newton to upward. No problem. It is still in the same direction. You remove it from here, you attach that to the bottom. No problem. Still in the same direction. Can you understand? If you apply any vector parallel in the positive direction, that is going to be considered as with the same magnitude, and same direction as an equivalent vector. Do you understand this or not? This point will be very valuable when you're solving things in vector polygon. This will be very important. So let me show you one example. There are certain vector systems that you have to solve, like in here. This is a hexagon. There is a vector here. There is a vector, and there. Sorry, I have drawn two more sides. Something. Okay, yes. Like this. There is a certain vector. There is a certain vector. Now you can't complete it. Sorry, not here. There is a certain vector. You can't just complete it because all the final vectors are here. Now you can remove this vector from here and put that to there. It is no violation because in the same parallel direction you lift it to up. Then you can just create the starting and final lines. You will understand why this, mostly in the next week, vector polygon, you can get the final. But what did I do was, I just remove the vector from here and attach to here. Now there is no vector. Can you understand? That type of things we will have to do. You have to remember this point that I gave you in triple stars. You won't understand what did I do here because I didn't teach you the vector polygon yet. But there are things like this to be done. So remember that point I said, okay, Ramai, now write negative vector. Negative vector. This is very, very important point. Start writing this. Negative vector. Okay, firstly have a good look at. Now there is a certain vector from A to B. A to B. That is vector X. Okay. Now you have to, it is like you moved like 100 meters to the A to B. Now you are coming back from B to A. The same 100 meters. Now the vector is BA. The previous one was AB vector. Previous one was what? AB vector. So you can also represent with semi-arrows. AB vector, X. Now this vector is BA vector down. But there is an unsatisfiable point. Why? I have violated something. I have violated something. What I have actually violated? The specific law I gave you. You can't change the direction. I said, once I fix the direction as that side, I can't turn and walk like this. What can I do only? I can move back while keeping the arrow still pointing to the positive direction. Understand? Understand? Still, my direction should be the positive. There. That is my direction. Okay. I can't move back. Have a look at. Now this is already violated. This is the way of doing it. AB. Now what you can do is, actually the vector is what? B A. Right? Not AB. It is BA vector. in the same direction, still in the same direction, but you did by force altering the symbol phi. It was AB. It was AB before. Now you put this B and A inverted. So you have to put a negative sign for that. So the vector will be minus x now in the same direction because you alter the orientation. So it's going to be a negative vector. This is the correct way. If you don't understand this, ask me 100 times even. Very important point. Clear, ne? You didn't understand. Seriously? How many others don't understand? How many others didn't understand? Just let me know. If you didn't understand, just put up it. I want to get certain idea. Everybody, just drop a message. If you didn't, so I didn't. That's it. If did, so I did. Drop me your status. Understood. Everybody. Yes or no? Yes for understood. No for. Mm-hmm. 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 Mm. Coco cut here. Mm. Yes. Mm. Mm. Okay. Okay. Enough. I will. Now A to B vector, you just start it from starting point is A, your finishing point is B. Imagine like you walked 100 meters to there. Now you want to walk back another 100 meters. But I told you, you can't change the direction once you fix the direction as positive there. You can walk, but in the reverse. Here what I have violated, I have put the arrow to the opposite. I can't change the direction of arrow. So it has violated. Now I actually want to move from B to A. Here the vector was from A to B. Now it is from B to A. You just inverted. See, AB. Now if you want to make BA, you have inverted these two twisted. So you have to put a negative sign to compensate for that inversion. That is why the vector is minus BA. So the resultant was like x to there, vector was x to there. Now it is minus x in the same orientation of the arrow. Okay. Understand? I don't know how to explain further than this. Okay, copy this, students. Very important thing to do. Okay, Lamai. Give me a 1 second. I will share you the live worksheet. Until that, you keep copying. Okay, I sent you the worksheet. That means the live worksheet for today. It includes some kind of very important theory for you to know and many more. Okay, many more. I hope you have copied. I hope that you have copied this. It has already taken 1 hour now. Students, hello. Okay, Ramai, write this in a new line. Addition and subtraction of vectors. Addition and subtraction of vectors. Addition and subtraction of vectors. Right. There are two more vectors. One is called unit vector and the other one called null vector. I'm not going to teach you that part because that is inside the tube. No need to complete notes with unnecessary amount of definitions. A unit vector means representation of what? Just a one unit of certain vector. Good example is 1 Newton, 1 meter, 1 ampere, like that. Only a one of these, one unit. Null vector means 0. No vector. The resultant vector is what? 0. So these scenarios, I have given you that in the tute. No need to copy those unnecessary amount of notes. Now just write addition and subtraction of vectors. Addition and subtraction of vectors. Okay, Ramai, the first thing, addition and subtraction of vectors. Now we have to write in a new line, write this addition and subtraction. Addition and subtraction again write it. Addition and subtraction have to perform under two different criteria. Two different criteria. What are the two different criteria? Number one is right addition and subtraction of what? Parallel vectors. Parallel vectors. Okay. Here I have given you a very good example in the first page of the today's online live worksheet. Let's put live worksheet. Okay. Now write parallel vectors. Second one is non-parallel vectors. Addition of non-parallel vectors. Addition of non-parallel vectors. Now write again that as a subtopic, addition of parallel vectors. Addition of parallel vectors. How? Now write, there are two ways of doing this. There are two ways of doing this. මේක කරන්න ක්‍රම දෙකක් තියෙනවා. There are two ways of doing this. Firstly, the first way is, now just write addition of vectors in the same direction. The subtopic under that first one. Addition of vectors in the same direction. Addition of vectors in the same direction. Have a really good look at now. It is like 8 Newton. You are going to add this with 6 Newton force. Okay, what is the resultant now? When you represent the resultant, you have to add double arrow and represent. Here you can see inertial direction of the first one to the right. Second one is also to the right. That means you can add these two together with no problem, right? There is no hesitation. You can add them and get the final vector as what? 8 Newton plus 6 Newton. So the resultant is what? 14 Newton to the right. Can you understand? You can simply add. Can you understand this? Okay. All right. When the vectors are in the same direction, can simply add them together. Can simply add them together and copy this as an example. Copy this one as an example. Okay. Finish this quickly. I think because of my shirt, it reflects more. I think it is also white, it reflects more. I will change the shirt and come. Otherwise, it will just reflect and you won't be able to see the things clearly. You keep drawing and I'll change the shirt and come because I can see some glitchy on the board. Now, still dark color, still some glitchiness is there. Okay, can you understand? Okay. Did everybody understood this? Hmm? Say yes or no. Okay. All right. Addition of vectors in opposite directions. Right? This addition of vectors in opposite direction. Let's see how we are going to add them in the opposite direction. Now the story is not same. Now the story is not same. Since the vectors are opposite to each other, right? This since the vectors are opposite to each other, have to get them into similar direction by changing arrowheads. 8 Newton. Here it is the 6 Newton force. Now there is a big problem. Why? These two are in the opposite direction. You can't keep it like this. You have to alter. Why? You took this one as positive. The other one is in the opposite direction. So what you should do is you have to alter this arrowhead to the same right hand side. You have nothing to do with the first one, 8 Newton. Now you have to put the arrow in the opposite direction. See? Now it is in the opposite direction, 6 Newton. But the problem is what? You change the direction. So it is no longer positive 6 now. Why? It is negative. Because you choose the change the direction of the arrowhead to the other side. To compensate that, you have to put a negative sign to this one. Can you understand this? This is very essential to understand because you have to bend this all 360, sorry, 180 degree apart. You have to flip this arrow. It was here. You change it to the other direction. Now it is a -6. So the resultant vector will be what? 2 Newton force to the right. So the final thing is something like this. Okay, 2 Newton. Resultant is what? 2 Newton. Okay. I hope everybody understood this. Is there anybody who couldn't understand why did I invert and why did it become minus and why final result is just 2 Newton? Yeah, we have to change the arrowhead to the other side. Get all the arrows to a common direction because I choose this direction as positive. So anything in the other side have to convert it to there. You have because you have chosen just a one direction. Okay. So all the other vectors you have to change to that direction. Okay. Understood or not? Huh? Clear, ne? Is there anybody who can't understand? Right. This is a very simple addition and subtraction. No problem. But problems will arise once the vectors are at certain different angle. When the vectors are in certain different angle, that is a problem. That's definitely going to be a problem. Now have a good look at here. Write the first thing. Okay, write the first thing. When vectors are in the same plane, open a bracket and write coplanar. Coplanar means, have a good look at, there is a one vector. This vector is also in the same plane, in the same direction. So we used to call them as coplanar in the same direction, parallel to each other. See, these two are in the same plane, parallel to each other, but in opposite directions. Now the thing is in the same plane, yes. But now the two vectors are pointing towards, let me just remove the caps. Now you can consider these ones as arrows to here. Now on the same plane, now in a different direction, like this. This vector is P, this vector is Q. Can you understand? Two vectors in two different planes. Can you understand? Yes or no? Good. You are going to drag certain vehicle or something in the car. You attach a rope to here. You attach another rope. One person is just pulling it by 100 Newton force. The other person is pulling it by 80 Newton force. But these two have an angle of 60 degree to each other. A real situation is something like this. Can you understand? Can you understand? Now imagine in such a scenario like this. Wrong marker, I think. 8 Newton and 6 Newton. Now you are going to write the resultant in what? 8 Newton plus 6 Newton. 8, it is like 14 Newton. Is that true? Is that correct? Is that correct? Definitely no. Because these are not actually in the same direction. You can't technically add like this. So to find the resultant of this, we have different methods. I told you there are 4 basic competence levels you have to know in A level. One is what? Vector triangle method. Second one is vector but a scale diagram. That is not much applied in here, but I will teach you how. That will lead you your knowledge to why we are deriving something like vector parallelogram theory. You will understand the scale diagram is very hectic and take more time and tedious. So here the other one is vector but parallelogram theory. Last one is vector polygon theory. You will have to know each other to learn how to get the resultant of a certain slanted vectors like this. So you would better copy all these 3 diagrams starting from here and the real scenario, real world scenario, and this one, and so that you can't do it like this. Do it quickly. Okay, Lamai? Okay? Understood? Somebody just dropped me a message. Can you just resend it? I couldn't read. When the vectors are in the same plane and in what? 2 different directions. That's the only thing I said. In different directions at an angle to each other. Okay. So I said only that. I didn't complete it. So draw it. So the next scenario is this thing. You have draw this, you have draw this, you have draw this. That's it. I didn't complete it. No need to complete. Okay. You have to write few examples. Understand? Now write this in a new line. There are 4 different methods of doing this. There are 4 different methods of doing this. Now write the first one. Vector triangle theory. Vector triangle theory. And the second one, vector scale diagram. Vector scale diagram. Now the third one, vector parallelogram theory. Vector parallelogram theory. Now the very last one is going to be vector polygon theory. That's enough. That's enough. Okay, now quickly write the first subtopic. Vector triangle theory. Write this in a new line. Two vectors, two different vectors at an angle to each other, at a certain angle to each other, two different vectors at a certain angle to each other can represent in two sides of a triangle. Two sides of a triangle. Okay, two sides of a triangle. And the resultant vector and the resultant vector and the resultant vector is represented by resultant vector is represented by what? Resultant vector is represented by the remaining side of the triangle. Did you complete the writing? Did you complete the writing? Now read it. Take 1 minute and read it. Take just 1 minute and read it. Even for me, when I was in schools, it took more time to me to catch it because they didn't explain it. They just gave the note and draw the triangle, and that's it. I had to come back home and study that and make my own triangle and identify. So I don't let you do that like that way. I'll explain everything quickly. I hope you're ready. Can you understand what is saying? When there are two vectors, you can represent one after another in like this way of two sides of a triangle and the remaining side, something. Wow. Have a good look at the first vector. I'll mark this one as P. There's another vector, Q. Okay. These are the two vectors I have. I have to represent these two vectors in where? In two sides of a triangle according to the vector triangle theory. I start Q vector and mark it. Your starting point, your finishing point. of the first finishing point. Now to construct a triangle, I want to draw P vector where you stop the first Q vector. I'm going to build that vector along here in the same direction. That is P vector. This is final finishing point. This is the starting point. I told you, whenever you are just going to get a vector, you are going to draw a line from starting to finishing and you find the vector. It is like this. Let me give you an example. You walk 30 meter and you turn to certain direction like this. You walk another 40 meter and you are actually bringing this on a ground. You mark certain point from A and you B, and you bring two different strings. One is a red color one, other one is a blue color one. You just went to B and mark tangle that in a certain point, and you drag it to here, and you finish at C. And you just stretch the other red one like in this one. You can directly find the direct distance by this string. Isn't that? Isn't that? Huh? This is the resultant. So your resultant should always the line you draw from starting point to the finishing point. Straight line you draw from starting point to finishing point. This is what the resultant. Now can you see your starting point? You went to there. You finally came to here. That is the one path. This is the other path. See, on these two sides, one side of a triangle, the next side of the triangle, this is the remaining side. The remaining side shows the magnitude as well as direction. Why? You can measure this angle as theta and find out where is the direction. Can you understand this or not? Huh? Is there anybody who couldn't understand? You can ask me. I will give you like 20 seconds to type the message and ask me. If anybody couldn't understand, I will explain it. No problem. Your appealing time is over. I think everybody understood it. I will explain that again. This Q vector I can represent here. The P vector, I start from there and construct these two sides. Now there is a one side I have to construct, and finally all three sides are done. The resultant of the Q and P all together is represented by the remaining side with the magnitude and the direction. Understood? Am I? Okay, that's done. I hope you copied this, ne? Did you copy the diagrams? I gave you enough time. Did you copy? Because I gave enough time. I don't know whether they are okay. Seems everybody copied it. Now, let me explain you. You can solve these questions according to our A-level standard only for one type of triangles. Those are the right angle triangles. Good example is if there is a 30-meter distance from A to B, you move another 40-meter distance from B to C. These two are perpendicular to each other. if now you are going to construct the triangles to find out the resultant, how you can use Pythagoras theorem to find out the answer. See, R is equals to what? Square root of 30 square plus 40 square, because in the last week I taught you enough of Pythagoras and I gave you a homework sheet to practice Pythagoras. That's enough. If somebody still can't understand Pythagoras, just drop a message. I will explain him or her about Pythagoras. Is there anybody who can't still understand Pythagoras? Just drop me a message. I will explain you Pythagoras first and go. Is there anybody who didn't study the midweek worksheet? That was a big midweek worksheet, man. My physical students, only 4 students has done it. They said, like, sir, you drop a certain study material. I thought it was as a study material. That was a very big but midweek worksheet. You had to study many things, but there were very few exercises for you to do. It was a big one. In online class, I only got like 3 worksheets. Very bad. I don't know why. Only 3 worksheets with the answers. Very bad. Now see, it is 900 plus 1600. So the resultant is what? 2500. So the resultant will be 50 meter in this direction, 50. Okay, copy this. You can do such a thing for right angle triangles. Okay. There is an outdated method. Some teachers still teach. That's why I'm going to mention this method. Okay, copy this. That is completely out of syllabus for now. It was very old syllabus, like 1990s thingy. Still very old teachers and who get lessons from all the teachers, even the teachers are younger, still used to teach those things. So I just show you the method. Don't write any note even. That is called Lami's theorem. You don't want to know because no question coming from that. If you just see this in some other's note or school teacher's note, you might think I didn't teach it. That's why I'm going to explain it. No need to take that note. Quickly copy this. Lami's theorem is something like this. If there are 3 vectors like P, Q, and R are applying like this, you just draw it. P. And the other one is like Q and R. Right. You mark 3 different angles like X, Y, and Z.